All right, back with part 3, and I promise not to keep you too long here. We've got a couple of quick homework-like examples to see if we kind of got out of the investigation what we were supposed to get out. We've got a function here, and we're asked to just describe the graph of it. Well, what are some key things about it? Well, we see that it's a degree 3, or cubic. Right? Because the highest coefficient on any, or highest exponent rather, on any term is 3, so it's cubic. So we're automatically thinking cubic S shape, right? Or whatever, a snake is what I called it. So we're thinking we've got that picture in our mind, but the next thing is the leading coefficient, right? So the leading coefficient is 4, which is positive, right? So which row of our thing are we're talking about right there? It's an odd degree with a leading coefficient is positive, so that means it starts low and ends high. So that means we know right away it starts low and ends high. Now, thinking this is one thing. We still have to be able to write the math. So starting is x being way on the left. Low is the y, describes the y being low, negative infinity, and ending, oops, ending is the x value going to positive infinity. Where does the y value end up? Positive infinity. What else? Well, we could describe some. By the way, this is talking about, this is the end behavior. If you ask about the end behavior, that's what we're talking about. What else do we know? Well, number of turning points. Do we know exactly? No, but it's a maximum of 2 turning points, right? Because it's cubic, it's 1 less than that. The number of zeros, maybe a maximum of 3, right? When we think of, if we are actually asked to sketch this, I suppose we could try a few other things, but we could try substituting in and getting a table of values grade 9 style, but we don't. We want to be able to do this very quickly. What do we know? We know it starts low and ends high, right? And then other than that, do we know anything about this? Well, we kind of know that it's normally this shape, right? It's normally snake shaped, but we don't know where the squiggle is, whether it's above or below, how many zeros does it go through, where does it go? Or maybe it's like the basic one that doesn't really have any turning points. We don't know, right? So we know just the end behaviors at this point. That's still more than we knew beforehand. Okay, example 2. I am a polynomial function. I am degree 4. I have 1 turning point, which is strange because we'd normally expect it to have 3. I have 2 zeros, and as x goes to negative infinity, y goes to negative infinity, sketch me. So notice, degree 4, we're thinking of m's and w's, right? I have 1 turning point, though, means something in particular as well, right? It means I'm not going to have 2 bumps. A normal m would have 3 bumps. So that's a bit strange. This is the big thing here, right? This is telling us something. As x goes to negative infinity, that's starts. Y goes to negative infinity. That's low. So it starts there, right? And so I can know that function starts low. It's given that to me. Because it's degree 4, though, it starts and ends in the same spot, right? The odd degree functions would start low and end high. So that means this one has got to end low as well. Having 2 zeros and 1 turning point, well, how can that be? It could be, there's several ways to finish this one off. One would be to think of it just as a slightly more boxy parabola. This would be, oops, I goofed that, a fine solution, just like this. That's one way. Another way might be, well, you know, maybe it has a dipsy doodle and one turning point. Or maybe the dipsy doodle is after the zero. But certainly all of them have two zeros and one turning point. And red, purple, green, we don't know. And notice that it could have went like that too. There are lots of different ways to satisfy this, but by the way, this type of question makes an excellent thinking question on a test. This idea of here's a description, you come up with either the graph or the equation. They make great thinking questions. All right, that's it. Homework time. Where's the homework? Is the homework on here? No, you got it on your page, I hopes. And there's a FAQ. And I know that just the nature of this class that you had the investigation was a bit strange, but I'm certain you'll get everything done and caught up. That's it.